Is it going? I suppose it is. Hello, Hythloday. I'm making a reply to your to a couple videos, but mainly the one. Well, not to a couple. I want to comment on the general topic, right? And taking maybe other things into account from past videos. But it was about discrete space, about an hour-long video, something like that. I'm wobbling because I'm standing on this thing. And I didn't put socks on, and these are not tennis shoes, so they're loose. But it's warmer over there in the sun. It's springtime. I mean, it's the unspring rather. Sorry, it's fall, of course, autumn, and these days it's been kind of like that. Like it's cold in the shade, and in the sun though you can get warmed up. So I wonder what a good place to stand. Okay, so because I got my see, these are two trees that have fallen down, who knows, a while ago. All right, one thing was, what did I write there? Oh yeah, electromagnetism and special relativity. That there actually could be seen as somehow special relativity says that they're the same field. Somebody derived that mathematically or something. I don't understand that. I uh, I get the concept that you used. I get the way you use it as a metaphor of, you can, uh, depending on how you interpret the parts of a thing. Once you get into stuff like this, um, you can have one four-dimensional thing or two two-dimensional things in combination. There's always different ways to split it up. But in that specific, I couldn't really follow why. Supposedly that's the case. That's what I'll do. I'll just sit in the sun, where it's nice and warm. Okay. Yeah, I'm feeling a little more settled. Here we go. Oh, the information inside the black hole. Yeah, that's interesting the way packing it in like that. I think that I agree. I think that it's going to be something like that. Like you have the ultimate information packing in. Susskind, of course, you probably have seen when he's talking about the amount of information that can fit inside a black hole is actually equal to the amount of information you can encode on its surface if you have Planck-sized bits, something like that. And they all seem to believe it. I don't understand that one either, but it's an interesting idea because it would relate the two-dimensional and three-dimensional world, which just by relating one dimension off, you get induction access into, sort of scoping of dimensions, possibly. So, and of course, this is when he's talking about this conservation of information. And okay, I'm fine with this zeroth law, but I don't necessarily take it at face value, let's say. Because, for example, we know you can't go back. It's kind of the idea, like just like you said it, that it's the information kind of brief interruption there. So, yeah, what was I talking about? So, it's not like you can always back up, was what I was going to say. Like in A New Kind of Science by Wolfram, that Mathematica guy, he demonstrates, and it's been demonstrated. But like cellular automata can make patterns, and they're definitely, it's just a sequential, very determined process, but you can't go backwards. Even though all the information is preserved, without the concept of throwing information away. That's the other thing. What about quantum erasure and ideas of throwing information away when you wipe it out and make it irretrievable to yourself? And in some sense, that's different use of the word That's a different sense of the use of the word information. I don't. Susskind isn't saying that you can't do that, that you can't lose the information. He's not saying you'll be able to reassemble it for real. It's more that the information didn't go away. So, like when you have the cellular automata, let's say the line-based ones, like Wolfram uses, if you know that thing. But anyway, so you know, you have a one-dimensional cellular automata in every generation. Subsequent, you can have pictures of it, right? So every line uh, can is calculated from the line before it. But that doesn't mean you can figure out what the line before it was, even if all the information that was in that last line got transformed into the new line. And all the information is there. You can't necessarily back out. It becomes more than one possibility. Like even calculating a hash is something like this in computer science. You know, it can go into the smaller number but not out. I mean, that's how like uh, your pair encryption tokens, where you know, you can't get you can't get your token back out. You can just put it in and unencode the information. So it seems like it is possible to, in some sense, throw information away. And he's talking about something different. It's like he's talking about the fact that if you throw information away, you're going to have to, that energy actually still goes out there. And it becomes heat, for example. And therefore, you know, it's still information. So this is different than what I think Hawking was originally proposing, where somehow you could wipe the information uh, totally clean. Like the way the information comes out has nothing to do with the way it went in. Um, and you know, I think that's not a settled matter whether they're right or not. Yeah, I know what. It's not a settled matter. Certainly, I don't know, but they're really happy with the way it turned out, of course. But you know, that's just could just be their pride and their accomplishments. It's hard to know how much of it is a real accomplishment in terms of some of the things they're saying about the black holes. I mean, Hawking made that bet with that dude, I forget his name, on Suskind's side, and he ended up paying it and saying, "Oh, I was wrong about the evaporation of information." Right? I mean, you watch those videos. I'm pretty sure you've seen this stuff or read about it. So, you know, what they were debating about was kind of on, you know, this different level. But that's great that Hawking was willing to see himself as wrong, but that doesn't mean he really even was wrong, right? There's still a lot of interpretation left to make, and there's still hard limits to what kind of experiments you can do. Though I think they showed you can observe black holes and learn things about them, like Hawking radiation. You know, they're like, yep, it's there because he predicted some of these signatures that you would expect of a black hole, and then you find it, and it's like, okay. So they've learned how to see with these objects how they should appear, but you're not going to probe inside them. And some of their theories talk about, you know, the information is encoded in such a way that, you know, I just had a weird idea on interpreting what they mean by encoding the information on the surface. But anyway, Susskind has talked about this idea that when the spaceship falls into the black hole, that it, you know, to us it looks like it's torn up, and inside the black hole it looks like it's still together, and that this is just has to do with the holographic rearrangement of the information. So I think that's hard to comprehend. And you know, it's one of those things that, well, maybe it's sort of a hint at to the weirdness of the idea to, you know, our common sense or my common sense. But it can't be, you know, the final view. There would have to be some other way of putting that. But I do believe that it's possible for the information to be like inherently complex like this, and where it is preserved is like the ability to do transformations from one domain into another. You know, there's a conservation of energy. What the heck are you doing? You want attention? Cats like when you go in the forest, like attention in the forest. They show up and say, why didn't you notice I was here when I was crawling on your back? I'm a tat. A tat. Tat. Hello, I would like to take over the video. My name is Ellie. I'm a female tat. I has attention. Okay. Dad. Okay, let's see. There, you have attention. Oh, do not do that. If you can't balance, you're not allowed to hold on with claws. Okay. I'm going to kick you off my lap if you claw me even a little bit anymore. Why do you need so much attention? You're ruining this philosophy video, making it about cats. Cats are not philosophicals. Okay, I'm going to get cat face now. Here you go. I'll rub that tat. Okay. So where I was going with that is basically this conservation of information idea allows that, you know, maybe the information can be really, really different. Like the information about you might be that you were torn up in a black hole, or you managed to fall through it, or at the last minute you were struck by a meteor and knocked out of the way of the black hole. And perhaps this multi-dimensionality idea is just the fact that, well, at some base level, your information about you, or about the universe really that you're a part of, is complex enough that it actually does accommodate being transformed into all of those different arrangements, right? So it's just like their transformation matrices, and the state of the world is complex enough to support all these different transformation matrices where the information appears different. It's kind of, but it's isometrically mapped into that, and so it can be mapped back. And so this multidimensionality that appears to us is obviously, the illusion would likely be that there's really just, you know, more dimensions of information, and I think humans can conceive of that, but you know, just because we have this three-dimensional space that our vision and other you know, main senses, the physical senses, input things into this spatial understanding, and to a certain degree our visual cortex, you know, kind of owns a lot of how we think of space in the most rigid way, because you have a sense of space. No, you were clawing my lap. You have a sense of space in see, your cat was bugging you too. It's like cats love philosophy of physics. They're like, yeah, we're ninja. What the hell? We love that we do that shit. There you go. Okay, I'll give you a scratch, but you're not getting on my lap. You clawed my knee. She said, well, I was falling. So anyway, the real state is some complex thing that can be projected through some transformation to look like, you know, irregular things like three-dimensional space, which is really the domain of eyes. And it could be the physics of eyes, you know. Like if you had a quantum camera, maybe you could capture more of the information than what our eye captures. Our eye captures this one scheme through it. And this idea of a conservation of information, that's what replaces determinism. Like various people, perhaps yourself, and I don't mean this in a derogatory way to say that there's like an emotional desire, meaning it's not a bad thing, but to replace determinism, something about the sure footing idea. And I think it's a conservation of information, and the fact that that's related to conservation of energy, conservation of mass. You know, the idea that there's a substantial something that can be conserved, right? That doesn't go away just because there's a transformation, right? That replaces determinism. Like my feeling of, well, where am I going to get a solid footing? I don't need determinability, certainly not in any absolute sense, because what I have is rules of information relationships, right? So it means I can deduce one idea from another idea, right? I can generate information about what's going on as an interpretation of information that I got from my senses. This mapping and transformability of information is what replaces any need for sort of this more certain and determinist idea. And you gain, of course, the statistics as a means of grading, the quality of your knowledge. That even if you have a perfect theory, there's going to be a plus or minus sort of, giving in to entropy and imperfection, and you need statistical samples and things to make certain kinds of statements. Otherwise, you get your plus and minus error bars. And so you don't need certainty, though, in order to have the feeling of a confidence in facts. If you have this conservation of information, and since information doesn't stay static, it's obviously transforming. So it means that every time you transform information, it produces what you put into it, just like slicing a pie. You slice the pie in 8, it doesn't get 8 times bigger. Now you get 8 pieces that are, an eighth as big as the original. And so it's the same thing with information. You can break it down and build it back up. And it's not going away unless you throw it away. You have to take one of the pieces. You take the apple and you peel the skin off. You want to remove the skin. Well, the skin's still there on your countertop. You're going to have to dispose of it if you really wanted to get rid of it. By default, it's all conserved. And this is where compelling arguments, really come from, is from that fact, right? And then the details, of course, of how ideas are work together. You said one thing that I was curious, it's just a semantic thing. It's like, you said you didn't believe in fields, and I remember you talked about this before. I've talked about it in the past. You don't believe in fields. It's just like numbers, in space, or spread out in space. And I think that's all that a field is supposed to be. I mean, saying there's a field is basically saying, oh, space has this other quality. It can have, a gravity vector at some point. It can have an electric or magnetic vector at some point. It can have various properties existing at that point. I think if we want to back off of that idea as relativist, it's like, well, if there is no particle at that point in space, I don't think it really has that gravitational vector. It's something about the relationship between things that exist. But you were talking, and we've been talking, and it's come up in science that, space might be made of some kind of particle, right? It's an interesting idea, and not just that it's discrete, but that it's like a little energetic particle. Like maybe you could, change space the way, you do things chemically, with chemicals, with molecules, that maybe you could affect space that way. But, so maybe it's not that every point of space has a thing, but I think the idea of field is basically just that. It's like, well, we parameterized over space again. That's a field. Anytime you have a parameter, a vector, a number of some sort, and it's different at every location, then, that's a field. And that's really, yeah, fields are spaces, basically, is the way I was thinking of it. But there's a semantic thing there. I don't think there's really the substance of a difference there. Just curious, because it sort of clicked with me that, oh, he thinks there's something ontologically wrong with the claim of there being fields. And I don't think there's a field. I don't think the questions of its ontology is really, it's not something I think about much. I do just think of it as values in space, basically. And it adds another dimension, because you can always kind of use, well, no, that's not true. I won't go into that. That would have been wrong. Okay. You were talking about in the video to Gary. Didn't take many notes on that, just one note, but talking with Gary about this stuff, you know, he has no respect for science of other people, and I don't understand how he can just bald-faced, you know, complain about the rudeness or the accommodations or anything. And you know, scientists are far from perfect, but in the physical sciences, you know, the idea that they're just following ideas like because the Pope said, that's ridiculous. You know, there's an element of that in the margin of the unknown. For example, there became a social pressure to believe in a gentle one, not intentional. You'd be encouraged to differ with it because that's what they do. But whatever, one way or another, supersymmetry had become a popular thing, and for decades they were basically telling us that they were on to something with this supersymmetry. Well, it predicts particles that have not showed up at the LHC, so there you go. On the other hand, what's going to happen is that the belief in supersymmetry meant that they wanted to build an LHC which would show these particles. It's one of the motivations of why they had reason to spend all the money building such a device, is because there was actually information they knew they could get from running the device. And without the particles showing up, theories have to go away. You know, they might reuse the name and kind of recharge it up, and oh, here's why it doesn't predict that right, and modify it again. But, you know, this is much different than the kind of biases, the infallibility of the Pope. You know, it's ridiculous. For somebody to want to be taken seriously, insulting those people is a waste of time, basically. You should take their numbers into arguments. And I don't know about anybody else, but to me an important part of this is sort of history of science and how we came to where we are now. And it is unacceptably naive, I think, to be arguing at this level where the personalities of the scientists are involved without really understanding how science, the Newtonian and classical science, or even going all the way back to Aristotle, did not want to accept its relativity and quantum mechanics. It was forced to. And to say that it was just a fad because of popularity, no, that's not true. It's just historically inaccurate. It's not like, well, maybe it could be true. Maybe that's how it was. It's like, make an argument for that based on some sort of historical fact, because that's obviously not the case. It's just not how it went down. So the purpose of the discussion is the grindstone.